Okay, in this video we're going to take a look at this Day 2 outlook from the Storm Prediction Center. This is the forecast for May 2019. You can see we have a moderate risk out for Texas and Oklahoma. So we'll go ahead and use Weathernerds to diagnose that area. So we'll jump into the Numerical Models tab and switch over to the HER since we're in the 1-day forecast range now. Let's drop back to the 0Z cycle. Then we can draw a box over our area of interest. And this case is a little bit interesting in that we're likely to get some nocturnal convection tonight. The mid and upper level forcing coming in with the trough out west is really strong in this case. And so let's take a look at what's forcing that convection tonight. And we'll go ahead and loop the 700 millibar vorticity. Just go out 30 hours. That should get us into tomorrow evening, tomorrow night. Can loop this. And it's interesting in that we have a short wave that kind of ejects out of Mexico and New Mexico. You can see it down here. It's this wave, and it kind of moves into the Texas Panhandle, becomes a little bit diffuse, but it's as thunderstorms are forming along and in front of it. So what we can do now is switch over to the simulated reflectivity to have a look at this feature. And let the loop load up for a second here. You can see there's the convection that fires along there. And what we can do to see how the two are tied is turn on overlays. And we can put that vorticity back on there, the 700 millibar vorticity. Just reload up again. Let that load. Go ahead and stop it here. So it's a little harder to see the vorticity when it's contoured like this, but this is our shortwave coming out of New Mexico and far west Texas. You can see the northern end of it starts to fire convection by 9Z overnight tonight. And as that impulse goes a little further into the Texas Panhandle, you can see it starts to develop convection, and that expands. And so now we're at 14Z, so 10 a.m. on the East Coast, 9 a.m. Central Time. There's 10, 11 a.m. Central Time, and we have all this ongoing stuff in our moderate risk area at 11 a.m. Usually not what you'd like to see if you're hoping for severe storms later in the day. But in this case, with this exceptional forcing and a deep trough that's not very progressive, you may be able to get away with it. And if I go out a little further, you can see the HER thinks we'll get a second round here tomorrow afternoon and evening. And if you're in central Oklahoma, you'll be under the gun, looks like most all of the day tomorrow and into tomorrow night. Okay, so let's drop back out of loop mode and go ahead and look at this in a little more detail. So I'll turn the overlays off, maybe zoom in a little further, and then I'll jump to, I always like to look at the surface dew point, see what the dry line's doing. You can see there are frontal features here, so then okay, let's go out to 18Z tomorrow. There we go, you can see our rather diffuse dry line out here and a pretty sharp warm front going just north of Oklahoma City there. And of course we have storms ongoing at this point. Let's go ahead now and overlay the wind shear. Let's do the effective layer shear. You can kind of see what we're looking at. As you can see already here at 18Z we have 70 knots of effective shear and dew points in the low 70s if we actually get that much moisture return tonight. So it'll be interesting to take a look at a sounding over there. See, good grief, that huge clockwise curving hodograph. So any ongoing thunderstorms that develop tonight, those will likely be elevated initially, but you can see in this sounding we're not capped. Surface parcels are free to be lifted into thunderstorms here. So if we have ongoing storms moving into the Oklahoma City area tomorrow afternoon, they should be able to tap into a very unstable boundary layer with extreme shear. So definitely a concerning profile there. That's just east of Oklahoma City, early in the day already tomorrow. So further west along the dry line, it's interesting, the flow is a little bit veered along the dry line. Let's go ahead and start going forward. So there's 19Z, 20Z. See that dry line tightening up. Actually turn off the overlay a second to make that a little clearer. It's still pretty diffuse there. 22Z, there's 23. Now it's tightening up. It's pretty tight, but it's also got a bunch of convection going on, making it a little bit cluttered out in front of that dry line. You can see the environment hasn't changed a whole lot in Oklahoma City. A stationary warm front-like feature here just north of there, and our warm moist boundary layer. So let's see 23Z. Let's take a look at the effective significant tornado parameter at this point. You can see some pretty huge values. In fact, right in Oklahoma City, we some pretty big numbers make a sounding in there. You can see we have an effective SIGTOR of 10 plus in here. And that curving hodograph again, lots of shear, 50 plus knots of shear, very low LCL. And look at this mixed layer CAPE of 4,000. So an extreme environment for a long period of time tomorrow in Oklahoma City with supercells around. So it's likely that any surface-based supercells that are tapping into this environment are going to produce tornadoes, probably strong tornadoes. So what else can we look at? We can go back over now and take a look again at the reflectivity. This time, this is 23Z. You can see it's pretty messy. Got storms all over the place, and let's take a quick look at the updraft helicity. See, we of course know with this environment these are going to be supercells, but it'd be interesting to see what we got. You can see, supercells all over the place. Not surprising. You can see these starting to develop off the dry line in the Texas Panhandle later on. But really along that warm front just north of Oklahoma City, much of the day, supercells going on in that extreme shear and extreme CAPE environment. So, continuing on here, you can look at instability, put on CAPE, see it's huge. Zoom in a little more. And then go ahead and overlay the surface-based sin and make sure we're finding areas. And there's large areas here where there's basically no sin and CAPE pushing 5,000 at least at the surface. So this flow starts to veer a little, which is interesting. But by this point, we've had lots of thunderstorms going on, and the environment gets pretty complicated. So certainly a dangerous situation in here. One other thing I did want to show was the storm motion. So we've got all these thunderstorms, embedded supercells going on, isolated supercells further west, and if we put on the bunker's storm motion, here we go. You can see we're looking at 40 to 50 knot storm motions through here, right into the metro area too. So just a really dangerous situation, especially if we get huge chaser convergence, which I'm sure we will tomorrow in this area. It's going to be dangerous. Be careful if you're out there. Keep a vantage from the southeast. Let these storms pass by to your west. This is a dangerous type situation. Okay, so another thing to do before we wrap it up is to zoom out and see what kind of targets might exist that are a little less traveled by so many storm chasers tomorrow. I'm of course in Florida. I won't be out there, but if I was, I might be interested in some of these other spots, like down here in Texas, and I thought I saw in the moisture field some moisture return sneaking up here into southeast Colorado. I don't know if the model actually generates storms here or not. We always like to look at this area. you can get some really nice storms in this this part of Colorado, and a lot of times sneaky like this. So let me see what the reflectivity is doing. Do we get any storms out here? Looks like maybe late in the day some of the stuff that develops off the terrain in Colorado rolls into that environment, but probably a little too little and a little too late to get a whole lot up there. So we may be stuck with this stuff in down here in the Texas Panhandle if we're looking for something less traveled by the chasers. So we can take a look at what this environment looks like down here. Put the surface winds on. So we do have some backed flow down here along the dry line. Let's see what our moisture field looks like down here. Yeah, it looks like these are dry line storms that have worked their way off the dry line into the warm sector. So let me get a sounding here. See what we've got along this dry line. Yeah, I mean, it's certainly good. That's obviously supports supercells. The LCL has crept up quite a bit compared to up in Oklahoma, but we still have huge Cape and some good severe parameters, plenty of helicity, and a lot of shear. So no reason there couldn't be tornadoes with those storms along the dry line down in Texas tomorrow evening. So that could be a good alternative if you're looking to avoid the crowd tomorrow. But anyway, that's a quick demo of using Weathernerds to diagnose severe environments. I hope you found that entertaining and maybe useful. And we'll see what happens tomorrow when the storms go up, and maybe I'll throw in some verification for this video later.